Hello everyone and welcome to this new video where we will talk about unit and scale setup. When working on a 3D project, it is not always essential to work at scale, but on the other hand it is very important if our aim is to print our work. Of course, because we want our project to be printed with the correct size, and when we do wargaming stuff, it is even more important because many things have a reglementary size, such as the base diameter, or if we want to model a ruler or a gauge, for example. Also, while modeling, it is also very important to keep the scale in mind, in order to balance correctly the level of detail needed for a model. It happens more often than you think to spend a lot of time on certain details of a miniature, and after printing, these details are barely visible, or maybe not visible at all. Let's start with the basics. Set the unit. For that, let's move to the Properties editor, and in the 5th tab called Scene Properties, we find a small panel called Units, and which simply allows us to set the units. So our first choice is, do we want to work with the metric system or with the imperial system? For my part, I'm not comfortable with inches, feet, etc., especially when it comes to manage decimals. So for this tutorial, I'm going to use the metric system. Okay, so what else to do? What we can do is create a simple object using this unit setup and check if everything is correct in a slicer. So let's create a 10mm cube and import it into a slicer. So 10mm is 0.01 meter. So here we have a reference cube. So I export it. I open the slicer and import the file. But damn, looks like we created the invisible cube. Let's select everything which is on the bed to find out where is our cube. We can see a gizmo, which means there is an object somewhere. Let's zoom in, and yeah, our object is there, but it's very, very small. It's much less than 10mm. So why is that? Yet we modeled a 0.01 meter cube. Well, the reason is, Blender scale is not the same as Lychee scale. But why 1 meter, an absolute value, can have a different scale from one software to another? Actually, in computing, the notion of distance does not really exist. Values that we manipulate, values I entered here to model the cube for instance, all that are just numbers. It's not like in the real world where 1 meter is relative to a physical reference. So in this case, why bother working with such or such unit system like the metric system? Well, actually it's just a reference. Even if this cube does not really measure 10mm from a numerical point of view, for the imagination of our project, to help us in the design, Blender reminds us that the cube is supposed to measure 10mm. So it's a bit like Blender displaying the units in meters to please us, but for him, it could be millimeters, centimeters, peanuts, or anything else, it would be the same. Okay, I exaggerate a little. Using a unit system still has an interest for the software as well. Using such or such units could be better to optimize the values to be computed. If you are working on an architectural project, for example on a 300-meter high tower, it is better to compute values in meters rather than millimeters, so that Blender will use numbers like 300 meters, rather than very long numbers like 300,000 millimeters. So, all that to say, in 3D, as in any computer program, softwares can display values with a physical reference like meter, but for them, each value is relative to a virtual or a generic unit. So if I create a 1 meter cube in Blender, the size of the cube will be 1 unit. So now the question is, how big is a unit in Lychee? Contrary to what I just explained about Blender, Slicers works with units relatives to something physical. For that, they need to have a reference, and this reference is simply given by the dimensions of the printer LCD screen. These dimensions can be found in the printer settings, and where we can see values displayed in millimeters. So that means Slicer's unit is millimeter, and so 1 unit is equal to 1 millimeter. To show you that, let's export our 1 meter cube, or rather our 1 unit cube. And now if we load this cube into the slicer, we can see that the cube is measuring 1 millimeter in lychee. And earlier when we imported a cube of 0.01 meter, in fact we imported a cube of 0.01 unit, or 0.01 millimeters in lychee, which gives us 10 micrometers. That's 5 times smaller than a print layer height, so obviously it was completely invisible. So once we understand that, we can simply model in Blender knowing that 1 meter is equal to 1 millimeter. For example, if I want to model a 40 millimeters base, I create a cylinder with a radius of 20 meters, so a radius of 20 units and a diameter of 40 units. I believe the height of a base is 4 millimeters, so let's enter 4 meters for the height. Then let's bevel the object a little just to make the object looking like a base. Like that, then I export the object and import it into the slicer. And thanks to the grid, we can check that the base is exactly 40 millimeters, because each tiles is measuring 10 millimeters on each side. So it's working! But we can make things a little more WYSIWYG in Blender, and for that we just have to modify unit scale. So back to the units panel, we can set unit scale in this field. Let's enter 0.001, so all values in our scene will be divided by 1000. So now our base has a diameter of 0.040 meter, but still 40 units. 40 units displayed multiplied by 0.001. So that's going to give us 40 millimeters in the slicer. That's more logical than before. On the other hand, 0.004 meter is obviously not an ideal value to manipulate. Indeed, if we use meters to model things as small as miniatures, we will always generate such numbers with a lot of decimal places. We can still enter values in millimeters. For example, if we create an object, I can enter 10 millimeters. It will work because Blender will convert the value to meters. Here's 0.01 meter. But it will be much better if all values in our scene were displayed in millimeters. So for that, we go back to the Scene Properties tab, and here we can ask Blender to show us all lengths in millimeters, i.e. by multiplying the displayed number by 1000 and put 2m at the end of each values. This won't change the unit scale, it is just a display preference. And finally, Blender use and display nice and WYSIWYG values in millimeters, like this base, a 40 millimeters diameter and 4 millimeters height cylinder, which will be correctly exported to the slicer as a 40 unit cylinder for the diameter and 4 units for the height. Let's check one last time if our configuration is correct by creating a 10 millimeters cube. So now I can just enter 10 and Blender create a 10 millimeters cube, then we export it and import it into the slicer, and they're using the grid tiles. We can see that our cube is really 10 millimeters. It's perfect. We can further improve our work environment by setting the 3D viewport grid. The grid has its own scale setting, so it's still set at 1. So here our grid scale is so huge compared to the scene scale that we can't even see it. So we're going to open the overlay menu, and here we can change the grid scale. So let's set here the same scale value as for units, so 0.001. And now, grid tiles are subdivided each millimeter. We can check that with our 10 millimeters cube, and we can see it's 10 lines wide vertically and horizontally. So here we go, we've set everything up to start a 3D print modeling project in good conditions. But be aware that each time you create a new project in Blender, all settings are reset, so I suggest you save this project as a preset file. I'm going to save this file to show you. Let's call it Start Project. And now if I create a new project, we can see that Blender has reset all the parameters. Unit scale has been reset to 1, the lengths are displayed again in meters, and the scale of the grid has also been reset to 1. Whereas if we start a new project from our template file, all the scene is already set up. Okay, now let's speak about the second topic of this tutorial, which is how to model keeping in mind the actual scale of what we're doing. This is something extremely difficult to be aware of, and there are several reasons for this. Overall, the screen is a problem. Despite the increasingly crazy quality of our screens, if we try to display a miniature at scale 1, so for me, it will look something like that. Despite the amazing quality of my loyal screen, we don't see much. The screen resolution is not good enough to clearly display a 4 cm model at scale 1. So what happened then is we always work by zooming such a lot comparing to the miniature actual size. And because we have the ability to zoom almost infinitely, using screens with diameters that can be up to 80 centimeters, which is 20 times the scale of a miniature, we end up completely abstracting the physical reality of our model. So it often happens that we spend several hours on details that, once printed, will barely be seen, and sometimes not at all. And that is really counterproductive, because instead of working on details which make sense at actual scale, which will give all its depth to a miniature, we drown the miniature in invisible details. About scaling details, we must recognize that Games Workshop has been really very strong at the time when miniatures were much smaller and made of metal with much less detail possibility than today. Sculptors always manage to give depth and life to their work, choosing the right scale for the right details. And for me, that's really what makes all the charm of old metal miniatures. So, to help us to break the screen glass, we can create real-world references into the software. The first thing we can do is to use the grid to give us a reference specific to 3D printing. We can consider the layer height, for example. Most printer cures layers of 0.05 millimeters high, so 50 micrometers. We can then say that 50 micrometers is the limit under which things won't be visible. So, if I want grid tiles to be as thick as a print layer, I can set a scale of 0.001 to turn the grid scale into millimeters, then multiply that by 0.05 to turn it into 50 microns, which gives us a scale of 0.00005 unit. So now if I create a small cube of 50 micrometers, we can see that the space between each lighter line is 0.05 millimeters. And with a front view, we have a representation of all print layer directly within Blender. And there we realize how totally disproportionate my level of zoom is. Yet I often work with this zoom level, but compared to the reality of 3D printing, it's as if we were working under a microscope. Once printed, the small 50 microns cube will be perfectly invisible. So here we have to be careful about that. So the grid set up like that, we can use it any time as a benchmark. For example, if I start modeling small details on the eyes, if I realize that this detail is not larger than several tiles, there for instance it's about 4 tiles, well I can say to myself, stop that. What you are doing will never be seen. Another example of using the grid as a benchmark, if we look at the eye's geometry, I can see that larger faces are about the size of a tiles. It therefore means that the eye topology, its subdivisions, is high enough to be very smooth after print. It is not worth subdivided more, but it should not be subdivided less. So it is a first approach, very technical but very effective. There are also other more sensitive ways that I also find very effective, such as the one proposed for example in Lychee. When we go to the Export tab, we have the possibility to display our models in a mode called At Scale. This mode simply places our modeling in a context with everyday objects. And it's very interesting because our brain is so used to these objects. It knows the size of a banana or a can of Coke so instinctively that we immediately have a good understanding of the object scale. There, for example, when we see the cube next to the banana, given the size, we could instinctively say that it is a dice, and therefore if we had wanted to model a dice, we could have checked that the scale is correct with a quick glance. And we can easily make ourselves a pretty much identical system in Blender. And this is what I did for me. I modeled my favorite coffee cup, the one I have every day on my desk, the one I hide so my girlfriend won't put it in the dishwasher. And if I want to check a model scale, I can display my cup of coffee. We're going to import it to show you. So to import a Blender file, we go to File menu and we choose Append. Then we look for the file. So here it's cup.blend, and when we hit the Append button, the entire file is not imported. Blender allows us to choose which data we want to append to our project. Here we want to import an object, so we open the Objects subfolder, and here all the objects contained in the file are displayed. I guess my coffee cup is called Bézier's curve, because I modeled it using a Bézier curve. And there you go, here is my coffee cup. And the fact of having it both in the 3D viewport next to my model and on my desk next to my screen allows me to be aware of my model scale with just a quick look. And immediately we realize that the scale of a miniature is finally quite small comparing to a cup. And when I zoom in like that, because my coffee cup gets so huge, it helped me to be aware my model is displayed 2 or 3 times bigger than it is in the real world. So if some detail seems tiny at this scale, they will be definitely invisible after prints. It also allows me to quickly adjust the zoom level of my scene to roughly match a scale one, using the cup on my desk as a reference. So obviously this coffee cup is not at all standard. It was a Potter friend who made it and offered it to me. So in the video description you'll find a link to download another mug, a model closer to the kind of cup everyone has at home. Well, I hope this will help you to better manage scales when you model with Blender. And that's it for this video. Thank you for watching it, and see you very soon.